Oh my gosh, y'all, I had to turn the camera off because I get confused on the signs. But I figured it out because when I did this, I didn't actually divide by the negative, right? When I divide by the negative, that flips the signs. All I did was rewrite it. I didn't actually, I flipped the position. This would be plus and this would be minus. So let me just redo this. So this would be h minus z equals mu d. So just divide by, we're trying to get d, so divide by mu. So then that's your answer. Now think about why this makes sense. Your distance, right? If I were to increase the mu, that would be a greater friction force, so it wouldn't be as far. So that would decrease. That makes sense. If I increase the height, I'd be starting with a greater height right here. If I started with a greater height, then I would have more energy, so it would take longer. So as h increases, this increases. Now I have a minus z. If I still have the same h, but I increase my z, then I would have less kinetic, so I wouldn't need to go as far to stop it. So as this increased, even though it's on top, because it's subtracting, right, subtracting a bigger number, that would make it decrease. So sorry about that. It's because I didn't actually divide by the negative. All right, last two. Small block of mass m slides along a frictionless loop. Leave the answers in terms of these things. The block is released from rest here, so this is just potential energy, K is 0. Find the velocity at point Q. So this is going to have some potential and some kinetic. Potential energy here is mgh, specifically has a height of 5r. At point Q, this is a circle, so the height right here is just the radius, so this has mgr plus 1/2 mv squared. M's cancel out, subtract the gr over, so I've got 5gr minus gr, which is just 4gr equals the 1/2 v squared. To get rid of the half, we multiply by 2, so that's 8gr equals v squared, so then now we just take the square root. So v is the square root of 8gr. We've got one end of the spring with a spring constant k, it's attached to a wall, and this is a distance h, a block mass is placed in front of it, and it's been compressed to distance x. The block is released and follows trajectory shown. I want to solve for this distance right here. So first of all, well, you can break it up into two different parts, it doesn't really matter. First of all, I'm going to look at it this way. This is a projectile. I know the y distance it's falling down is h. I know the acceleration, just this part's acceleration is g. It's going to come off horizontally, which means my initial velocity is 0. I'm going to use this to find time, and then once I have time, I'm going to use v equals d over t to find the distance. That means I need to find the velocity that's coming off with. If you think about it as energy from here to here, right here I have spring energy, and then it's going into all kinetic energy. So my 1/2 kx squared is going to equal 1/2 mv squared. Your halves are going to cancel. To get v by itself, divide the m over, then take the square root. So the x velocity it's coming off with is square root of kx squared over m. So that is my x velocity right here. I'm looking for the distance, so before I can plug in v equals d over t, I need to find the time. Change in y equals v naught t plus 1/2 at squared, h equals 0t 1/2 gt squared. Multiply by 2, divide the g over, that's t squared, so t is the square root of 2h over g. Now lastly, I'm looking for d, v equals d over t, multiply this up, so distance is velocity times time. We just got the velocity, and we just got the time, square root of 2h over g. And then you should always think, does this make sense? If I were to increase the x, if I were to push it back more, now it would be storing more energy, so it would come out with a faster velocity, that would increase d. If I were to increase the table h, I would still come off with the same velocity, but now I would be moving at that velocity for a longer period of time, because it would take more time to fall down, so then that would increase the distance.